Good afternoon. My presentation will be a bit more technical, focusing on TGDF and TGDL. So requirements on Part L and Part F that I'm going to focus on are for new dwellings. L1 with regard to limiting the amount of energy required for the operation of the building and the amount of CO2 emission. And this is a problem here. So this is done through a deep calculation, and only using deep, no other software. Okay, there are other requirements listed in the Regulation 8 and with regard to the minimum amount of renewable energy, which is your RER, which is also calculated with DEEP, limiting the heat loss and appropriate weighting of heat gain to the fabric of the building. The Regulation 8D providing commissioning energy efficient space water heating systems with efficient heat sources and effective controls. E providing a minimum efficiency, seasonal efficiency for gas and oil boiler of 90%. And the last one is F, which is becoming new EPPD, the 2024 recast EPPD, which is very much focusing and shifting the focus from safe and energy efficient building towards safe and energy efficient building with zero emissions, and which guarantees a healthy indoor climate for the occupants. And that's where it is important to have those provisions in TGDL and TGDF, and that requirement, Regulation 8F, on providing the homeowner with sufficient information to operate and to maintain the systems. That links to Part F. We've got a requirement as well that I'm not going to cover on the EV charging infrastructure, which is falls under the remit of my colleague Idel Murray. This requirement, which is more than a requirement, a new requirement introduced in 2022, and efficient district heating as an alternative to renewable energy sources. So I'm going to focus on prima facie compliance from TGL and TGDF. For new dwelling, issues to be addressed in order to ensure the compliance falls under two categories. One for the whole dwelling performance. The calculations are carried out under DEEP, and you need to achieve MPPC, maximum permitted energy performance coefficient of 0.3, and MPCPC, maximum permitted carbon performance coefficient of 0.35. That is equivalent to 70% on the 2005 regs. What's important is that this calculation is done on the as-built dwellings. Together with that, we've got a set of individual minimum performance levels compliance, okay? And that corresponds to TGL sections 1.2, the renewable energy ratio. You must use at least 20% of your energy from renewable sources produced on site or nearby. You've got backstop U values for the fabric, elemental backstop with backstop values for the area weighted average, and maximum U values for individual elements in Table 1. You've got an alternative option here with regard to the maximum area weighted average U values by using a combined heat loss backstop value for the whole fabric in paragraph 1.3.2.3, and that's taken into DEEP. Thermal bridging in LCDs, the remit of my colleague Simon McGuinness, who will be presenting separate. Maximum air permeability of 5 cubic meters per hour per square meter to ensure that you have airtight dwellings and you limit heat losses. And limiting heat gains in section 1.3.5. Building services are covered in section 1.4 with minimum boiler efficiency for gas and oil of 90%. Space heating controls, insulation of hot water storage vessels, pipes and ducts, mechanical ventilation system efficiency, and EV recharging infrastructure. Permissioning is covered in the section 1.5, and user information under 1.6. And user information, as I said, is going to become more and more important. Cover that. So the total of the parts that gives you compliance with Part L dwellings. So that's a deep Part L compliance report example. And so it has to be for the final, for the as-built building, so it's the final document, the final BR assessment. Published, you can see the watermark with the BR number. This is not the provisional BR assessment, which is not published and with a draft watermark. Okay, so for Part L compliance, you need to have the published document. So my presentation has been slightly changed. So in this document, you will have the EPC and CPC compliance that are summarized in the document, and you have the R greater than 20% just underneath. I hope that works. No, that doesn't work. So the compliance with the area-weighted average U-value, backstop U-values of column 2, table 1 are done separately, and just underneath the column 3 compliance to the maximum elemental U-values. That alternative, so reasonable provision would also be achieved. The total heat loss through all the opaque elements did not exceed that which would be the case if each of the area-weighted average U-values set out in table 1, column 2 were achieved. So that allows some flexibility. In this case here, you've got a U-value of 0.9 for the walls, which is above the backstop U-value of 0.18. But however, using 1.3.3, the total heat loss through the fabric is less than what it would be using the backstop U-value of column 2, table 1. In that case, it is important to remember that for the ground floors, incorporating underfloor, the maximum U-value is 0.15, not 0.18. There is no relaxation on this. And installation. NSAI has published a set of SR standard recommendation documents, which covers this, puts the references, and the 4 documents of the NSAI SR series are available at a discount cost of €100 from the NSAI. So they cover heat pumps, solar thermal, and all water-based heating systems for dwellings and hot and cold water supply. You also have templates available in our document Achieving Compliance with Part L and Energy Performance of Building Regulations 2019. Works should be carried out in a workman manner. So we provide competent persons, so sources of competent persons for the installation of renewables are available from ACEI, registered installers, and SOLAS. And as mentioned this morning, series is coming live. In 2020, series would be a registration to series would be a legal requirement for all providers of work, and it's going to be an online register of competent builders, contractors, and specialized subcontractors and tradespeople. So that will cover after next year's first division of dwellings providers of duplex and triplex buildings, housing schemes greater than 10 units, and apartments and blocks. So we'll have ventilation installers for after that, and other families such as heat pump installers. All new dwellings should be tested for their tightness and should have attained an air permeability of 5 cubic meters per hour per square meter max. So we currently have, there should be, we have 102 registered individuals on the NSAI scheme and 4 accredited organizations with INAB. So these have been growing, these cohorts of professionals have been growing over the years. And the tentative layer should provide the building control officer and the homeowner with an air tightness test report with the applicability not greater than 5 cubic meters per hour per square meter. This is very important because this dictates the ventilation strategy. And you should have part A and part F working hand in hand, and this is quite important. This should be checked by you. In 2019, and this is why this is important, we introduced provision for CMEV, continuous mechanical extract ventilation, which you can use for any air permeability below 5, same with MVHR. And natural ventilation was retained for air permeability between 3 and 5 only, and background ventilators with 40% larger. It is important if you are below 3, okay, you cannot use natural ventilation. So if you have a design stage, a design that includes natural ventilation that requires an applicability of 3 to pass and to be compliant, that should raise a red flag. Okay. Currently, around 75%, 80% of the new buildings are using mechanical ventilation. The average air permeability is around 2.6. So we can clearly see that the market is moving towards very airtight dwellings using mechanical ventilation. Ventilation should be designed by competent designers. They should be installed by competent installers. And there are several courses available here. And when commissioned, so they have to be commissioned, then they should be validated by an independent competent person from NSAI or INAB, accredited by INAB, to ensure that they achieve the design flow rates. Control in a visible location to the occupant and not in a remote location. And they should indicate to the occupant the system is operating correctly and if a fault has occurred. So once again, this is very important, especially with what's coming down the road with EPPD and the importance of having healthy climate indoor climate. Sorry. Information earlier, the owner should be provided with sufficient information about the ventilation systems and their maintenance so that an effective and efficient ventilation system can be operated and maintained. And the department has issued in plain English for homeowner on the importance of ventilation in your house and a video. And it's work. There's currently research in University of Galway on the importance of the occupant behavior and achieving good indoor air quality. And that other organizations like the IGBC have published a plain English guide for homeowner user guide to ensure good usage of the dwellings and proper indoor environmental quality. Templates for different ventilation strategies are available in our guidance document, Achieving Compliance with Part F. Other documents are available from CIBSI and the BSRIA guide, BG 49 2015, that was just updated last year. ISEN 14 can also be used, and this is used for the ventilation validation scheme by NSAI and INAB. Finally, for ventilation systems that do not illustrate prima facie compliance, that means for mechanical ventilation systems that do not provide at all times the calculated general ventilation rate. In that case, the NSAI agreement cert includes an agreed and assessed process of validation. Currently, we've got 61 validators registered with NSAI and 3 organizations with INAB. So once again, this cohort of professionals is growing. On arrival on site, the ventilation validator shall be presented with 3 documents: the ventilation design with the design airflows calculations, the air tightness certificate that dictates the ventilation strategy, and commissioning report. Okay. Once you have that, the validator will assess that the presented design flow rates satisfy the minimum provisions in TGDF 2019. And then they shall proceed to take the measurements in accordance with IACN 14134 and then issue a mandatory ventilation validation certificate. What you have on that certificate, so you have the design, flow rates for supply and exhaust, the measured flow rates for a boost and trickle, whether the design airflow rates are achieved, and any comments in that validators would put, such as, for example, the under-door cut of 10 mm is not available. Once again, just user information from TGDL, that the owner should be provided with sufficient information about the building, and in a way that the house can understand. It should be related to what has been installed, of course, and the adjustment, the control, and the routine maintenance. And as well, just to remind that the air pressurization test report should be included in the user information pack. Similar wording, the homeowner should be provided with sufficient information about the ventilation strategy so that it can be operated in an effective manner. It could consist of a suitable set of operating and maintenance instructions in a way the householder can understand, and of course directly related to the installation in the dwelling. Where the filters are located, the controls, how they work, why it should not be switched off, and why you should clean the filters and how often. Okay. Conclusion, just a list of documents that should be could be asked for. So confirmation of use of proper material, and that may require an NSA agreement cert. Design certificates, deep partial compliance of the as-built dwellings, a valid air tightness test report for all new and dwellings supporting the ventilation strategy. Okay, a valid ventilation certificate, from an independent competent person that the ventilation system achieves the design flow rates, and the information pack. What next? 2024 recast PPD is coming. As I said, we're going to focus on more than safe, energy efficient dwellings and move towards safe, energy efficient dwellings with zero emissions and a healthy indoor climate. Just a couple of references from SCEI and the NB MSO resources. Now I leave the place to my colleague Samuel McGuinness to talk about thermal bridging and SEDs.
Thanks, Emmanuel. Is this ready to go? Very good. Good afternoon, everybody. My name is Simon McGuinness, and I'm here from Building Standards to explain bridging. So, of our policy in relation to thermal bridging are twofold. The first is to limit heat loss through thermal bridging, and heat loss in thermal bridging is nothing to be to ignore. Some apartments in Dublin have been measured at 50% of total heat transmission heat losses are through the thermal bridges. So this can be a big number. So the aim of the policy is to avoid excess heat loss through thermal bridging, and to avoid surface condensation risk causing mold. We do this through what's popularly known as the FRSI calculation. So I'll deal with the requirements for dwellings. Second schedule of the building regulations require designed and constructed to ensure that the energy performance of the building is such as to limit the amount of energy required for the operation of the building and the amount of carbon dioxide emissions associated with this energy use, insofar as is reasonably practical. Technical Guidance Document L, paragraph 1.3.3.1 outlines what we consider to be a reasonable provision. So to avoid excessive heat loss and local condensation problems, reasonable care should be taken to ensure the continuity of insulation, to limit local thermal bridging at key junctions, i.e. around windows, doors, wall openings, and junctions between elements. And any thermal bridge that there is present should not pose a risk of surface or interstitial condensation. So this is the FRSI part of the requirement. Appendix D2 provides for further information on assessing the surface condensation risk, how you assess that FRSI issue. And Appendix B3 provides information on assessing interstitial condensation risk. So this would be through mold growth or condensation happening within the thickness of the construction. Both should be avoided. Now, combining paragraph 1.3.3.2 and 1.3.3.3 into this kind of handy-ready reckoner chart, we've got 4 ways of dealing with this. The first is to use acceptable construction details for all the junctions. If you do use the ACDs for all the junctions, all the key junctions, you can claim a 0.08 Y factor for your building. So that's a significant improvement in the energy calculation by reducing from the default down to 0.08. You can also use acceptable construction details with certified details. Sometimes manufacturers have certified details that are in some cases better than ACDs. You can use a combination of those two in a calculated Y factor calculation. So by combining certified details with ACDs, you can usually improve on the 0.08 Y factor value. So it's really worth pursuing. A lot of developers are now finding that they can quite easily achieve 0.5 for a Y factor, which cuts down on the amount of insulation they need to put into the building, or the amount of solar or the quality of other parts of the building can be reduced to compensate for that. So developers are already exploiting this quite effectively at the moment. The next option is to use certified details for all junctions. In this case, you're probably using a thermal modeler to put together a calculated Y factor for the building. And then the fourth is to use alternative details which limit the risk of mold growth and surface condensation to those set out in paragraph D2 of the Appendix D, in which case you have to use the 0.15 default, except there's a little asterisk beside that, and I'll explain what the conditions associated with that. Remember that the aim of the policy is not just to avoid heat loss, but to avoid mold growth through surface condensation. So the alternative details, which are anybody's detail, must limit the risk of mold growth and ensure that surface condensation is accepted at an acceptable level. That's the terms and conditions of using alternative details. They must achieve this mold growth avoidance. And the way we prove that is by applying the provisions of Appendix D2 of Technical Guidance Document L. So that effectively needs an FRSI calculation for every junction. You have to prove that you've achieved the FRSI if you want to claim the 0.15 default thermal bridging factor. And a lot of people don't get that need. You're in very risky territory if you're applying the 0.15 default U value or Y factor. And because you're in that risky territory, you have to prove that you've met the minimum surface temperature for each junction. There's supplementary guidance has been produced. In general, the feedback I'm getting is that it's not known about. So what I'm going to do is show you how to find it and then why you should read it. So the first point is to find the supplementary guidance. If you search for TGDL in a Google search, you come to this page. The very first on the list is gov.ie, Technical Guidance Document L, Conservation of Fuel and Energy. That's just with the search term TGDL. When you click on that document, it leads you to this page, which is the landing page for Technical Guidance Document L. And item 4 on the list is acceptable construction details. People say they have difficulty finding this. I think I've just shown you a really simple way of getting there. Now, within that, there are 2 parts to the guidance in relation to acceptable construction details. Part 1 is an introduction, and it outlines the general theory of insulation continuity and air tightness. Part 2 is the ACDs themselves, which we are well known about. So just to look at the introductory document first, part 1 discusses the general theory. As I've said, this is what it looks like. You've probably not read it. It's really a good idea to go home and read it now. Proposes a common approach to the design, construction and testing methodology and makes suggestions for general improvements in the construction process. So things like we've included intermediate floor details for the first time, and then it's illustrated with photographs, describes the construction and highlights the critical parts of the construction. Window surrounds, again, showing how the window can be sealed effectively to be airtight. Those kind of details are really, I think, very helpful to the industry. When we go on to part 2, the acceptable construction details are 7-fold. There's the cavity wall insulation that people will be familiar with. There's external insulation, internal insulation, timber frame, steel frame, and hollow block construction. So there's, 6 different types of construction that are covered by ACDs. We also have general details that apply to most other parts of the building, internal wall junctions with floor, roof, and ceiling, for example. But bear in mind that of those, 2 of those are to do with external and internal insulation. And in that respect, they can be applied to major renovation work. So we've had feedback to say that, well, there's no ACDs for retrofit. There are. They're called the external insulation and the internal insulation details. And if you use those, you can claim the FRSI and you can claim the SI values that are in Table D of Appendix D of Technical Guidance Document L. So it's really important within each group of ACDs to read the introductory text. Most people, these are the terms and conditions. This is the small print, if you like, for using the ACD. If you read that text carefully, you'll find that the masonry materials shown on the diagrams are bricks and blocks. Other masonry materials, including precast and in situ concrete, may be substituted without loss of thermal performance or increased risk of surface condensation. And where these construction details are used, Appendix D of Table 2 and the SI values associated with that can be used. So we do have ACDs for major renovation. So how do the ACD assist designers? So this is a typical ACD. You'll notice that the date is 2021. We revised all the ACDs in 2021, and you should use the new details because they're much more representative of the kind of construction that we're using now in Ireland. The insulation thickness is to scale for the first time. The width of the cavity is to scale. All of those kind of things we just really assist designers. But effectively, you've got the thermal performance, the air barrier, and the achievement of the critical surface temperature covered by the ACD for different parts of the ACD. And then you've also got guidance about what else to look out for, other parts of the building regulation, particularly Part B, in relation to fire, where there might be a critical issue. In this case, it's closing the cavity above the insulation. So the use of ACDs during construction enables the designer or the builder to demonstrate that the provision has been made to eliminate all reasonably avoidable thermal bridges in the insulation layers. That's the purpose. Sorry, this has gone awry. So the application from SEAI is another document that should have and be referring to regularly. It's a calculation tool for the Y factor calculation, and I put a link on the slides here to bring you directly to that page of the SEAI website, which holds the calculation. And it's a case of choosing the ACD, picking it from a list, and telling the length of the ACD, and it will assemble, by doing that for each junction in the house, it will assemble a Y factor for the entire building. And these are not, these can be used for all kinds of buildings. So the Y factor calculator from SEAI is recommended. And that's it for me. Thank you very much.